All right, in this problem, we are given an equilibrium constant for the reaction, and we are told that it exists at a certain set of conditions. What's going to happen as the system reaches equilibrium? And the first answer is it might already be at equilibrium. How do we tell? We calculate Q. So we're looking at that reaction. It's up here. And we write our expression for Q, which looks exactly like the expression for K. Q just means it's not necessarily at equilibrium. So it'll be the concentration of C times D over the concentration of A cubed and B. So that is the expression for Q. It's also the expression for K. The difference is Q means it may not be at equilibrium. So let's see if it is. Here are the conditions. As we look at it, we're placing them in a 12-liter container just to make the math harder. Let's see, my C, I've got 0.1 moles of C, so 0.1 over 12. I've got 0.9 moles of D, 0.9 over 12. I'm plugging in the molarities. 2 moles of A, so I've got 2 over 12 cubed. And 4 moles of B, so I've got 4 over 12. And then I plug that in my calculator and solve for Q. You should be punching it in as I do this so that you can double check. Take me just a minute. All right, I'm getting Q is equal to 0.405. All right, so as I'm looking at my answers, it looks like a couple of the answers are the matching the 0.40. And notice, since that is not the same as the value of K, it is not at equilibrium. So the reaction is going to have to shift one direction or the other to reach equilibrium. The question is, which direction does it shift? Well, if Q is greater than K, and that's the case here, it's 0.405 and K is 0.0021. If Q is too big, Q needs to get smaller to reach equilibrium, to reach the same numerical value as K. And think of how does a reaction shift such that the numerical value gets smaller. Since it's products over reactants, it's going to shift back and produce more reactants. So it's going to shift to the left. All right, Q is bigger than K, Q is too big, and it needs to get smaller. And since Q and K are products over reactants, that means it's going to shift to the left. Well, as it shifts to the left, notice that this is in terms of the amount of D. As it shifts to the left, it's going to decrease the amount of D. So Q is equal to 0.40, a little bit of sketchy rounding, but we'll go with it. And the system reaches equilibrium by decreasing the amount of D.